Hello everyone, myself Professor Hemant Azanpure from Kekewag Institute of Engineering Education and Research from Applied Science and Maths Department. Today we are going to discuss about unit number 4, that is probability distribution, and from that the topic is normal distribution. So normal distribution is continuous distribution. It is derived from binomial distribution in a limiting case when n is very large and neither p nor q is very small. The general equation of normal distribution is given by y equals to f of x, and it is equals to 1 upon sigma into root of 2 pi e raised to the power minus 1 by 2 into the bracket x minus mu upon sigma whole bracket square, where mu is the mean of the distribution and sigma, that is the standard deviation. Now let us see the normal distribution curve. It is always symmetric about mean. Some points which we required in solving the example. The first one, in normal distribution, probability of x lying between x1 and x2 is given by the area under normal curve from x equal to x1 to x equal to x2. Means in short, finding the probability is nothing but finding the area between the 2 points. The second point, the total area under the curve is always equals to 1. The curve, you can see that total area of that curve is always 1. Then the next point, z equal to x minus mu upon sigma. You will have to find the probability for x that we will convert in terms of z. Okay, where mu is the mean of the distribution and sigma is the standard deviation of the distribution. Now let us move toward the example. First example, in a certain examination test, 200 students appeared in a subject of statistics. Average marks obtained were 50% with standard deviation 5%. How many students you expect to obtain more than 60% of marks, supposing marks are distributed normally? In bracket area is given. Okay, in bracket area is given. It is 0.4772 for z equal to 2. Now average, that is mean, which is given 50%. So now 50% means 50 upon 100, which is equals to 0.5. Therefore mu is equals to 0.5. Standard deviation they have given, it is 5%, that is 5 upon 100, which is equals to 0.05. And standard deviation we denote by sigma, so sigma equals to 0.05. Now we have to find probability of x greater equal 60%, means probability of x greater equal 0.6. For that, let us standardize it, means let us convert that x in terms of z. How to convert? For that, z equal to x minus mu upon sigma. Therefore, it is equals to x. Put the value of x there, that is 0.6. Okay, minus 0.5 upon the value of sigma, that is 0.05, and it is equals to 2. Come to the next step, and hence probability of x greater equal 0.6 is equal to probability of z greater equal 2. Means we have converted that value of x in terms of z. Now we have to find the probability of z greater equal 2, means we have to find out the area which lies above z equals to 2. So for that we know that the total area is 0.5. So half of the area, total area is 1. So half of the area is 0.5. So from 0.5, as we require the area only above z equal to 2, so let us minus the area from z equal to 0 to z equal to 2. That area is given. Area corresponding to z equal to 2 is given, means it is the area from z equal to 0 to z equals to 2. So that's why subtract that area of z equal to 0 to z equal to 2 from 0.5. So it is 0.5 minus 0.4772 and it is equals to 0.0228. And therefore it is a probability, and we have to calculate now the number of student. Therefore number of student expected to get more than 60% marks is equals to 0.0228 into 200, which is equal to 4.56, means near about 5. So 5 students are expected to get more than 60% of marks. Okay, so this is the first example. Now let us move toward the next example number 2. Assuming that the diameters of 1000 brass plugs taken from machine form a normal distribution with mean 0.7515 centimeter and standard deviation 0.0020 centimeter. Then question is, how many of the plugs are likely to be approved if acceptable diameter is 0.752 plus minus 0.004 centimeter. In bracket area is given. Area is equals to 0.474878 corresponding to Z1 2.25. That is, this is the area from Z equal to 0 to Z equal to 2.25. And another one area is given, another area A2, that is 0.4599. It is corresponding to Z2 equal to 1.75. That is the area from Z equal to 0 to Z equal to 1.75. So see the given things, mu that is the average, mean it is 0.7515, sigma that is the standard deviation which is equals to 0.0020, and the acceptable diameter is in between 0.752 plus minus 0.004, means you will get the two values of x here. First add these values, means first of all let us consider x1, which is equals to 0.752 plus 0.004 and it is equals to 0.756, and x2 equals to 0.752 minus 0.004, which is equal to 0.748. So for these values of x1 and x2, we'll find now z1 and z2. We'll standardize it. X will convert in terms of z. So you can see here z1, x1 minus mu upon sigma. So substitute here x1, mu and sigma. You will get the value of z1 as 2.25. And the value of z2, it is x2 minus mu upon sigma. So put here again x2, mu and sigma, you will get minus 1.75. So probability of x lying in between 0.748 to 0.756 is nothing but probability of z lying in between minus 1.75 to 2.25. Okay, so now finding the probability, that is nothing but finding the area. So we have to find out here the area which lies in between the points minus 1.75 to 2.25. So for that, see, area corresponding to z equal to 2.25 is given. That is the area from z0 to z equal to 2.25. That area is given. But now in the example they have given the area for z equals to 1.75, right? 1.75. So as the curve is symmetric, means area from z equal to 0 to 1.75 will be same as 0 to minus 1.75. Okay, means from minus 1.75 to 0. So you can see here in the diagram that area is also available, and hence just add these two area, you will get the area from the point minus 1.75 to 2.25. So adding this area you will get 0.9477. So it is the probability, and now we have to calculate number of plugs likely to be approved. So it is equals to 1000. Total 1000 plugs are there. So we'll multiply that 1000 by the probability, that is 0.9477. So it is equals to 947.7, means near about 948 approximately. Okay. So now let us move toward the next example number 3. Third example, in a sample of 1000 cases, the mean of certain examination is 14, standard deviation is 2.5. Assuming the distribution to be normal, find the number of students scoring between 12 and 15. In bracket, areas are given corresponding to the point, 0.4 and 0.8. These two areas are given. So now see, mean is given, which is mu, it is equal to 14. Standard deviation sigma 2.5, and question is find the probability of x lying in between 12 and 15. Again standardize it. For the values of x, 12 and 15, we'll find the value of z. How? By using the formula z equal to x minus mu upon sigma. So z1 equals to 12 minus 14 upon 2.5. It is equal to minus 0.8. And z2 equals to 15 minus 14 upon 2.5 equals to 0.4. So probability of x lying in between 12 and 15 is nothing but the probability of z lying in between minus 0.8 to 0.4. Means we have to find the area lying in between minus 0.4 to minus 0.8 to 0.4. So see, the area corresponding to 0.4 is given, that is the area from 0 to 0.4, that is 0.1554. You can see that in diagram. And corresponding to 0.8 plus 0.8, the area is given, but as the curve is symmetric, so area will be same for minus 0.8 to 0. So that's why that area you can see in the diagram, it is 0.2881. Okay, and hence as we require to find the complete area from 0.8 to 0.4, that's why we'll add both the areas. So it is equal to 0.2881 plus 0.1554, and that is equals to 0.4435, and hence you will get the number of students scoring between 12 and 15, and it is equals to 1000 into 0.4435, and that is equals to 443.5, and it is near about 444. Means 444 student can expect to have the score between 12 and 15. Now let us move toward the next example number 4. The height of the student in a school follows a normal distribution with mean 190 centimeter and variance 80 centimeter square. Among the 1000 students from the school, how many are expected to have height above 200 centimeter? In bracket, area is given 1.118, corresponding to 1.118, area is 0.3686. So see, mean, that is mu is given, it is 190. Variance means sigma square, which is equals to 80. So take the square root, you will get sigma. that is standard deviation 8.9442. Now we have to find the probability of x greater equal 200. Question is, how many are expected to have height above 200 centimeter? That is, we have to find probability of x greater equal 200. So for this value of x, we'll find z. So that z is equals to x minus mu upon sigma, and it is equals to 200 minus 190 upon 8.9442, and it is equal to 1.118. Means probability of x greater equal 200 is nothing but probability of z greater equal 1.118. Means we have to find out here the area which lies above 1.118. So for that, see, the total area under the curve is 1. You can see the diagram. Total area under the curve is 1. Half of the area will be 0.5. So now as we require the area only which lies above 1.118, so we'll subtract that area from z0 to z equal to 1.118. That area is 0.3686. That will subtract from 0.5, and hence you will get 0.1314. It is the area which lies above 1.118, and hence number of students having height above 200 centimeter is equal to 0.1314 into 1000, so which is equals to 131.4, that is near about 131 students. Now come to the example number 5. Assume the mean height of soldiers to be 68.22 inches with variance 10.8 inches. How many soldiers in a regiment of 10,000 would you expect to be over 6 feet tall, where data is normally distributed? In bracket, area corresponding to 1.15 is given, which is equal to 0.3749. So see, here again mean is given, which we denote by mu. It is equal to 68.22. Variance is equals to sigma square, which is equals to 10.8. So take the square root, you will get sigma, that is the standard deviation, 3.2863. Now we have to find probability of x greater equal 6 feet. 6 feet, you just convert that in inches, so it is equals to 72 inches, because 1 feet is equal to 12 inches, so 6 feet will be 12 into 6, that is the 72 inches. So now for x greater equal 72, we'll convert in terms of z. What is z? Z is x minus mu upon sigma, which is equals to 72 minus 68.22 upon 3.2863, which is equals to 1.15, and hence here probability of x greater equal 6 feet is equals to probability of z greater equal 1.15. Means we require to find out the area which lies above 1.15. Again the total area is 1, half of the area is 0.5. So out of this, the area from z0 to z equal to 1.15 is given, which is 0.3749. So we'll subtract that area from 0.5. You will get 0.1251, and hence calculate the number of soldiers. In a regiment there are 10,000 soldiers are there, so 10,000 multiplied by the probability 0.1251, so you will get the answer 1251. So these are the number of soldiers you expect to be over 6 feet tall. I hope the topic is understood to each and everyone. If you are any difficulty, you can ask me by WhatsApp or by message. Okay, thank you all.